Hey folks, welcome to my channel Number Pen. So there we have the problem on the screen. Integrate the following with respect to x. And we have tan inverse of 8x divided by 1 minus 16x square. So what we've been given is dy by dx and we've been asked to find y. And my y is nothing but integral of the given expression. So let's write down what is my y. So that's my y. So I know that my y is not in a very simple format whose antiderivative I know from first principles. Neither can I apply integral by parts directly, right? So I don't think I have it in the UDV format. But I do notice that inside the tan inverse, I have an 8x divided by 1 minus 16x square. So can I connect this with any of the trigonometric identities that I know? And whenever you have a tan inverse, try to connect the expression inside 8x divided by 1 minus 16x square in this particular case with another tan related trigonometric identity, right? What could that be? And by practice, you would be quick to realize that the formula that I need to use in this particular case to simplify this expression is 2 tan theta divided by 1 minus tan square theta equals tan 2 theta, right? So let's write that down. And why do you think it is best to use this particular formula? Because when you look at the expression inside tan inverse, I know that with a little bit of modification, I will be able to immediately relate it to this particular identity. So let's do that in the next step. Integral of, I can rewrite my 8x as 2 times 4x, right? And my 16x square can be written as 4x the whole square, right? And now when you try and connect this with the tan 2 theta identity, it becomes very easy for you to identify what is that substitution that I'll have to make, right? So the substitution that I'll have to make is 4x equals tan theta, right? So when I do 4x equals tan theta, what happens to my dx? I differentiate on either side, I get 4 dx equals secant square theta d theta. It means my dx becomes equal to secant square theta d theta divided by 4. So now I have my x in terms of theta, I have my dx also in terms of theta. So if I go back and put back everything in my y expression, can I rewrite this y in terms of theta, and does it become a lot more simpler than what it looks right now, right? So let's do that. Y equals integral of tan inverse of, when I do 4x equals tan theta, what does my expression inside the bracket become? It becomes 2 tan theta divided by 1 minus tan square theta, which is nothing but a tan 2 theta, right? And then I have my dx. My dx is nothing but secant square theta d theta by 4. So I just copy paste and replace my dx with secant square theta d theta by 4. Now I know that my tan inverse of tan 2 theta is nothing but a 2 theta. Okay. So let's write down our new expression in terms of theta. So I have 2 theta because I have a tan inverse of tan 2 theta. And then I have a secant square theta d theta by 4. So I know that my 4 in the denominator is nothing but a 2 into 2, and I can cancel one of the 2's with the 2 of the 2 theta in the numerator, and I'm left with 1 by 2 times, and I can pull that 1 by 2 outside the integral, right? 1 by 2 times theta into secant square theta d theta, right? That's what I'll be left out with, right? Now, how do I go about solving this? This is not too difficult, at least by now, because we have solved even more complex problems than this using integral by parts. So I have integral of u dv And the expression that I have is indeed in that particular format, u dv. So I have integral of u dv equals uv minus integral of v du. So which is that u that I will have to choose? Is it theta or secant square theta in order to enable solving this for me in just one single step using integral by parts, right? It is u equals theta and my dv equals secant square theta d theta. And I have this to solve for this particular problem using integral by parts. I need my du and v, right? My du is d theta and my v is nothing but integral of secant square theta d theta, which is quite familiar to us, which is a tan theta, right? We know this from first principles. So I have my u, I have my v, I have my du, I have my dv. So all that I need to do is go back and put it on the integral by parts identity, right? So remember, folks, I'm just picking up integral of theta secant square theta d theta, right? And we have our half still left out, and we will come to our y once we solve for integral of theta secant square theta d theta, right? So what is my uv? My uv is nothing but theta tan theta, and then I have a minus of integral of v du, right? Now what is my du? My du is nothing but d theta, my v is tan theta. So I'm left with integral of tan theta d theta, right? So what is my integral of tan theta d theta? My integral of tan theta d theta is nothing but log of mod of secant theta plus c, right? So I have the answer for integral of theta secant square theta d theta, which is nothing but theta tan theta minus ln of secant theta plus c, right? And remember, folks, I have my mod here. So what do I do now? I go back to my y and I rewrite this because my y is half of integral of theta secant square theta d theta. Therefore, my y is equal to half of the expression what I arrived at just now, right? This is what I have as my final answer, but I know that I cannot leave it in terms of theta because what I've been given, okay, in the initial question is in terms of x, and therefore I'll have to rewrite everything in terms of x, right? Now, what is that original substitution that I made? I made the substitution 4x equals tan theta, right? So when my 4x equals tan theta, what is my theta in terms of x, right? My tan theta is 4x, and when my tan theta equals 4x, my theta is tan inverse of 4x, right? And then I have a minus of ln of mod of secant theta, right? Now this requires a little bit of working because I know that I have my 4x equals tan theta, but I will have to express secant theta in terms of x, right? This is where I want you folks to remember that secant square theta minus tan square theta equals 1, right? Which means my secant square theta is nothing but a 1 plus tan square theta, which means my tan theta was 4x. Therefore, my secant theta is nothing but a square root of 1 plus 4x the whole square, which is nothing but a 16x square, and then I have my constant plus c. So can we do any further simplification on this particular expression? I have half of 4x times tan inverse of 4x minus ln of mod of square root of 1 plus 16x square plus c. I don't think I can do any further simplification. Therefore, let me call this my final answer, highlighting it in pink. I hope you found my content useful. please do subscribe to my channel and support.